if you know the slope or gradient of the curve, and you also know where the curve cuts the y-axis, suppose it cuts at a point where the value of x is 0, that means at the y-axis x equal to 0, and the value of y is c, meaning it cuts the y-axis at the point c, then the equation of that line is going to be y equals to the gradient of the line x plus the y-intercept, meaning where does the line cut the y-axis of that particular line, and that's all. The first examples, work out the gradients of these lines, work out the value of c in each case. This is pretty straightforward. So y equals to mx plus c is the form we are talking about. So here the gradient is minus 2 and the y-intercept is 5. Here the gradient is minus 1, coefficient of x, and the y-intercept is 7. Since y-intercept has x-coordinate 0, so if you have to write down the point of the y-intercept, that would be 0, 7. Here it would be 0, 5. So the next one, the y-intercept is 4, meaning the coordinate is 0, 4, and the gradient is 3. And finally, this one is a bit different because it's not arranged in the format of y equals to mx plus c. That means we might have to rearrange it before we can actually say anything about the gradient and the y-intercept. So it would be, if I take the equation as it is, and I send everything to the other side, so minus 4y equals to minus twice x minus 5, multiply both sides with minus, that would be 4y equals to twice x plus 5. Now divide both sides with 4, it would be y equals to twice x plus 5 divided by 4, so it would be twice x by 4 plus 5 by 4. So the gradient would be 2 by 4, meaning half, and the y-intercept would be c equals to 5 by 4. So the point would be 0, 5 by 4. So remember, if it's not in that format, you have to rearrange it in that form.